final methodology presented in this module is life cycle assessment, or LCA. LCA is an assessment of all processes included in the manufacturing of a good or a service going from the extraction to the end of life phase. As you can see in this diagram, the LCA of a product looks at all the inputs and outputs necessary during the extraction, manufacturing, transportation, use, and disposal phases. As for material flow analysis accounting, LCA benefits from a well-established methodology. This methodology is defined by the ISO standard 14040. The standard defines LCA as a technique for assessing the environmental aspects and potential impacts associated with a product by compiling an inventory of relevant inputs and outputs of a system, evaluating the potential environmental impacts associated with those inputs and outputs, and interpreting the results of the inventory and impact phases in relation to the objectives of the study. In general, four main phases, iterative phases, are carried out when doing an LCA. The first phase defines the system boundary, the functional unit of the product, for instance, 1 square meter of bricks, and the goal of the study. In this phase, all assumptions and limitations are explained. The second phase is the most important because it details all of the inputs and outputs necessary during all of the life cycle stages of a product. This is called the life cycle inventory. The third phase is the life cycle impact assessment. This phase gives an environmental impact for each of the flows identified in the previous inventory. The environmental impacts include, for instance, global warming potential or eutrophication of water bodies. The last phase is the interpretation of the results phase. This part identifies how to reduce the environmental impacts of a product and gives recommendations. To perform an LCA, data can be found either directly through industries or through LCA databases that are described here. The main advantages of the LCA methodology is that it has a harmonized methodology and therefore enables a comparison between different products and services. As input-output analysis, it also measures all indirect and upstream flows that are usually omitted in urban metabolism studies. Finally, it complements all input and output flows with their environmental impacts. Let us finish the description of accounting methodologies by listing the shortcomings of LCA studies. Firstly, let's mention that system boundaries are often chosen arbitrarily by assessors. This means that two studies assessing the same product could provide completely different results. The second and perhaps most important limitation of LCA is that it's mainly targeting products. Some studies have managed to assess the environmental impact of all products within a building or even a neighborhood, but doing an LCA at an urban scale would be extremely time-consuming as the number of products and services circulating within a city are countless. The last limitation of LCA studies is that they often can't specify where the environmental impacts of input and output flows are taking place. In this module, we presented 4 accounting methodologies that can help us measure the resource use and pollution emissions of cities. Each methodology presented different advantages and disadvantages and offered different insights for policymakers. In case you want to do an environmental assessment of your city, you'll have to choose between these methodologies depending on the data you have, the data availability, and depending on what your main objective is. In case you want to see some examples using each methodology, you can follow the link of the screen to have a look at different studies.